Hi, welcome to the lecture on session 8. So this one deals with wireless LAN channels and channel plans. So now we know we've got 2.4 gigahertz channels and we got 5.0 gigahertz channels. In 2.4 gigahertz channels, there are 14 channels that are available in the 802.11 standards. Most regulatory domains allow for only channels 1 to 11. But do know that there are other regulatory bodies that may allow, for the additional 3 channels. Now in this case, you're seeing 14 channel bands on the 2.4 gigahertz. But to minimize the overlap of channels, what you want to make sure is you don't want, because you look at here, you look at channels 2 and channel 4, they overlap. So what you're looking for, because what we've talked in the past, that overlap causes interference. So what we're looking for is enough space between channels to minimize that co-channel interference. Now, so in this case, in a 2.4 gigahertz channel plan, the normal channel that guarantees no co-channel interference is channels 1, 6, and 11. Now, as much as we'd like to say, hey, here are the standards and this is what you should have, it's not always followed. Now, if you look at the chart below in that 2.4, because we do have some protocols that allow for a 40 channel, 40 megahertz channel width. And as you can see here, you can still get away with 1, 6, and 11 to still fall into that realm. So just keep that in mind. Now, if you look at the 5 gigahertz plan, it definitely has a whole lot more 20 megahertz channels than the 2.4. In fact, it has like 25 channels, but again, regulatory domains can support, they can have them, but support them, but don't necessarily allow that to come into play. So now with the way this is set up, there's definitely far more than 3 channels like we had in the 2.4 gigahertz range. So you've got some benefits. Now, the big benefit in 5 gigahertz, they don't overlap. In 2.4 gigahertz, either whether they're 20 megahertz or 22 megahertz wide, they're all based on the centerline frequency. So, for example, channel 1 is based on the center frequency of 2.412 gigahertz and uses, 10 megahertz below that midpoint and above. And channels are only 5 megahertz apart from each other. Therefore, channel 2, which is centered at 2.417, and it would definitely give you an overlap. Now, in a 5 gigahertz, they don't overlap the same way. Channel 36 centered at 5.180 gigahertz, and channel 440 is centered at 5.200 gigahertz. Both channels using 10 megahertz below and above the center, but you can see that the center, channel 36 ends at 5.190 and 40 begins, and there's no overlap in the main channel. So 5 gigahertz definitely gives you some options. Now remember, with 5 gigahertz, you also have 40 megahertz, 80 and 160 megahertz channel bandwidth. Highly don't recommend using the 80 and 160, but definitely can get away with the 20 and the 40, which we've used probably in your 802.11n in AC protocols, which allows for multiple frequency widths. So keep that in mind as far as width. So 2.4, you got to worry about. You only got 3 channels to play with because of the overlap. 5 gigahertz, you've got probably 25 channels that they're separated far enough apart that there is no chance of doing operation. Now, just to give you a rough idea, some of the best practices when you're thinking about channel planning is choose a channel that has the least activity in the targeted area. Sometimes you get 802.11 and non-802.11 devices like video cameras, microwaves and stuff that, especially in the 2.4 gigahertz range, that operate in the same frequency or the same channel and causing you interference. Understand that channels must be staggered throughout a deployment for something called frequency reuse, which allows you to make sure that you have especially if you have multiple access points, you don't want channel 1 and channel 1 nearby. You want to make sure you got maybe one on channel 1, one on 6. You want to make sure there's separation between them so that you can not cause your own self some interference. You can use the 40 megahertz channel for standard office deployment in 5 gigahertz only when the clients need some extra, momentary. Otherwise, it's probably still better to use the 20 megahertz bandwidth for the 20. Avoid as much as possible using 80 megahertz channels, and definitely in an enterprise deployment, do not use 160 megahertz. Even though the standard's there, you're not going to help anybody. So, just to give you a rough idea what we're talking about with co-channel interference. Co-channel interference, you may hear it called co-channel contention or co-channel cooperation, but the 802.11 standard uses the phrase co-channel interference. So I think you want to make sure you get used to that. It also uses the phrase co-channel overlapping BSS interference, which basically is a long way of saying the same thing. So just co-channel interference. And what you're seeing here is an example of co-channel interference where I've got 2 access points, 1 computer, and they're both on channel 1. So when you think about trying to come into play, what channel to use, you want to make sure that when you got 2 devices, they can only hear 1 channel. So you want to make sure your basic service sets, the BSS or your access points, are on different channels so that when a client is trying to set up on it, it's got a distinction to choose from. Now, based on some of the technology using which protocol you're using, you may want to disable some of the slower speeds. Because remember that what happens, since a radio can, in most cases, can only operate at 1 channel, 1 frequency, 1 speed at a time. If somebody logs in with a slow device, guess what? Everybody's got to go to the lowest common denominator to come out to make that transition work. So to maximize the throughput and the speed, it's sometimes better to disable some of the lower speeds, like the 1 or 2 megahertz in a 2.4 megahertz, just to prevent clients connecting at that low speed. So those are just some things you want to keep in mind. Now remember, co-channel interference is caused by channel access method, because of what we're using to allow people to get access. This access method requires people to listen before you talk. approach to communication. Each station must listen to the channel, must verify no other devices are communicating before a transmission. Note that it is not that listening for other devices in the same BSS, but listening for any 802.11 devices communicating on the same channel. So if there's communication, it must wait until it ends and usually implement a random back-off procedure before they try it again. But when you have multiple BSSs in the same area, on the same channel, you could get some co-channel interference. So I hope this gives you a brief coverage of channel plans and some of the best practices. If you have any questions, let me know. Have a nice day. Bye-bye.